Hey, this is Coffee Compiler Club. We're here today to talk about compilers and language runtimes and whether or not Cliff can read people's names off their monitors and find them in my spreadsheet, and properties and binary ASTs and converting yet another programming to run on the JVM. Anyhow, you're all being recorded live. It'll show up on YouTube in a couple hours. And with that, Yasser wanted to say it was his first time here. I swear I've seen you here before. But since you're claiming first time, maybe give me a 30-second intro.
Yeah. Can you guys hear me, by the way?
Yeah.
Yes.
All right. So, let's see. I'm a mostly C programmer who's working on a C front end and custom back end that's supposed to eventually become a replacement for LLVM. That's like the gist of it.
There's a goal.
Yeah.
That's it? You're just going to say I'm replacing LLVM and not going to go into detail? Come on.
I can touch into it. I just don't know how long 30 seconds is. Let's see.
We're going to go past 30
doing
seconds now. I asked for more, so all bets are off.
So there's a few big changes I'm doing. So one of them is fixing some of the parallelism issues that LLVM ran into, like they just never fixed.
Are you fixing LLVM or are you replacing LLVM?
I am replacing LLVM. I am more so combating some of the criticisms that I have of LLVM in my own solution. And so one of them is that every time that you want to create a module and then do multi-threading on it, you just can't like if I have two functions, I'm building them separately, I'm compiling them separately, I'm optimizing them separately. I can't do that. It just gets messy. And then so fixing those kinds of problems, I'm doing C of nodes because I picked it up at some point, like maybe 5 or 6 months ago. I had heard the term before, but I had never looked into it. And then so once I looked into it, that was really interesting, and that's kind of what got me here. And then the other thing is that I'm really interested in compiling big projects in the single process. And so there's a bunch of things oriented around that, usually to do with like, okay, we can multi-thread, we can do linking as a library. So like that's just another export feature with the linker being like, oh, you want to pass me an object file, parse it, and then give me the contents, or I'll take the contents as like in the file system and then I'll parse it, and then we'll work from there and just keep appending things to an exported module.
Does the project have a name?
Yeah, the backend is called TB. It used to mean something, but it doesn't really mean anything anymore. I could drop a link though.
I'm sorry, it used to mean what?
It used to mean something. It doesn't really mean anything anymore.
Okay.
Yeah, it's just like I think I stuck with tilde.
Is it anything available online or open source? Yeah.
So the backend, they're all in a mono repo, so I don't know where I should drop the link. Should I drop it in the Google Docs?
Yeah. It's all public.
All right.
Don't give away any secrets you shouldn't give away.
Yeah.
Let's see, either terabyte or tuberculosis.
Oh, I thought it was T. Yes, okay, fine. To be done.
Yeah, and then there's that's where the backend lives, basically.
Anonymous hamster. All right, we'll have to go look for 10 seconds here. I'm doing my 10-second look. Read me. There's at least a read me. Tilde backend. 01 level passes. What's 01 level passes?
So mainly it means a crap ton of peepholes and then converting like stack variables into like phi nodes and such.
Okay. Well, okay. So SSA form then.
Yeah, basically.
Yeah.
It's like it's still like a modded linear scan register allocator. It's got a bunch of peepholes to do with things like converting branches into branchless structures. What's another fun one that I've got around there? Just like general optimizations around like constant folding. Yeah, all the fun stuff.
0, multiply of 1.
Yeah.
You reassociate integer arithmetic math around addressing expressions to force all constants to be in the same side so they fold and stuff like that. Okay, fine. Yeah. But you're not in SSA yet at some point. Sounds like you just said, well, we're going to get. Or you're not putting
it's all in SSA. I actually even do like some of the more memory SSA stuff where I'm passing around like stores and stuff. I haven't gotten through some of the oddities of merging memory. So that's like probably going to be one of my next goals.
Okay. Yeah. The slides I pass around here about SSA form and optimizations, the second half of one of those talks goes to an example where I hoist fields into basically registers into SSA form and then optimize on that. And that's like C2 does that is a big thing. It works fairly well.
Yeah, no, it sounds particularly helpful because if I can get aliasing info out, which is really hard to do in C, but if I have a language where I can get it out, then it's really valuable to be able to do so because people write code that has things used at their sort of like latest points.
Yeah.
And then I don't necessarily want them to be computed at their latest points.
Right. The sea of nodes graph directly represents an equivalence class aliasing, and C folks often go to what I would call an oracle model or a points to model, which they're not the same.
Mm-hmm.
To the extent that you can coarsen whatever aliasing you're getting out or computing into an equivalence class, then when it goes straight into the sea of nodes, you get to drop all efforts of aliasing information anymore, and it peoples all just work and things fold up just how you expect them to. But it has to start with an equivalence class.
For me, the basic thing is just going to be I don't necessarily care too much about C aliasing and figuring out aliasing there. Instead, it's basically just going to be get something like restrict to work so that I can do the kinds of things I might want to do with arrays there. And then everything else, I'm just going to probably invest in other languages that might do aliasing a bit better.
Yeah. Okay. Yeah. Yeah. You know, if you didn't cheat at the C rules, you could do okay, but everyone does.
Yeah.
Fine.
Undefined behavior for the win.
Yeah.
What was the hardest thing to implement in C of nodes?
I don't think I had any like strong like stories. I think it was less about anything being hard to implement. It was more about like realizing like the implications of it. So one of the big ones I ran into was to do with the sort of like rewriting like doing scheduling again and saying, oh, okay, so like in SSA CFG, you're effectively always in a scheduled form, even though you don't necessarily like use that scheduled form in the final output, as in like you will be shuffling things around a lot. And there's disagreements between what the scheduler might want and what a platform independent like IR wants to represent. And like those things, like realizing, oh, I can say that memory is actually like another value I can pass around, or control flow is another value I can pass around, and representing those dependencies separately is like sort of, it was like, you know, kind of mind boggling at the start.
Excellent. Yeah. It's just fun for me because I you know ran through this whole process when I was a grad student, you know, 4 years ago, and then watching it happen again to other people later is kind of fun, kind of odd, kind of fun.
Yeah, the fruits of your labor.
Yeah, exactly. What else was going to say here? Oh, did you find the global code motion paper, or did you do something different for final sketch?
No, I basically ended up just doing like that whole thing verbatim. It's
Okay.
I think there's a few things that I'm going to end up doing once I start to like get more deeply into optimization, but I'm hoping to self-host this year, and then once I self-host, I'm going to move on to prioritizing optimizations, because usually I just do it as like I'm bored, I don't want to work on like the main compiler, and so I'll just do it there.
Yeah, do a fun optimization. Move on.
Yeah, and so the big one is going to be things like I want to get something like STB image working through my optimizer, and then like start perf testing it as like, oh, how fast can I load a PNG or something?
Yeah, that's a good one. Yeah, something.
Yeah, in which case, things like scheduling late and early, and prioritizing like, oh, we want to schedule late or early because we're, you know, around a loop or something. Stuff like that.
You want to know where the high frequency blocks are, which generally loops, and then you want to be out of the high frequency blocks.
Yeah.
So whether that means before or after, according to which one. Yeah.
Do you have like a performance goal in mind? Like, are you trying to be roughly as fast as both GCC and Clang? Or
in terms of like output?
Yeah, compiled code speed, not the speed of compiling code.
In terms of compiled, in terms of like compile times, generally speaking.
No, performance wise.
Performance.
Like
okay, so
benchmark numbers.
Yeah, I hope to eventually reach like, like maybe like 90% of like Clang O2 or something like that. Like if I can do that, I will be happy because everyone that want to sort of convince to use my backend is like mostly bought in as like we want something that's simpler than LLVM so we can hack it, so that we can have parallelized compiles that can actually work within one process without needing to make a bunch of modules that you need to like stitch together. They want things like just a simpler like type system, because LLVM's type system gets really messy, especially.
Oh yeah, that's why I just use text, because I don't have to deal with their API, their type system, and it was pretty straightforward to do to launch multiple processes. But I had to do that for TCC as well.
Yeah. I don't doubt that it's possible to reach like 100% of what something like Clang 2 does. I just wouldn't aim for that because I don't necessarily care actually. Because one of the issues I ran into is that I don't know if I need it for most of the projects I write. Like a lot of these sort of like more niche optimizations, I don't know if they like actually affect the sort of runtime like performance of most of my code. I'm sure they affect somebody's, but I've never really seen it materialize like that.
From what I notice, when I compile with GCC, it's typically faster than Clang. But I also noticed that Clang can compile certain things faster. So I think like 100% doesn't make any sense, because
But
it would have to be
when you say
100%.
faster, you mean benchmark speed, not compile speed.
No. Like binary efficiency, like how fast the binary is.
Yeah, benchmark numbers.
Yeah, benchmark numbers.
I can go run this program in 10 seconds. I can go run it in 9 seconds. Oh, I can go run it in 8 seconds. Who's faster on the generated code?
Yeah, so generated code, I was because it seems like Clang, certain things are faster than GCC. So when it says are you as fast as like Clang, like 100%, it would only mean for the certain use cases that Clang is good at. But then GCC beats it in a bunch of others. So it's just like
Sure,
I
yeah,
would
it's
not
hard.
go
It's hard to
100%.
measure these things.
Well, you have to get
Yeah, it's just
large
certain things I would want to be
and
good.
statistical analysis and stuff like that. Yeah. Pick your poison. I think you get within 90% of Clang on almost anything, you're a long ways along. Getting to 90%
I
on
pretty much
everything, pretty big deal.
Yeah. I don't really care how fast slow code goes, but I do care how fast code goes. So that's another thing that.
Well, then you have to tell what's fast and what's slow. I have this theory that I can put a keyword down. You can tell me what do you think should be fast, what should be slow, and then I can pay more attention.
Would your code be linkable with other compilers' output? In which case, you can always shortcut to compiling critical stuff elsewhere until you get it fast enough.
Yeah. So I've technically done this where so like I don't compile my own version of SDL, and so I've like linked against that, and like I do link against external code. I can produce object files still. That's like generally how I do things. So I'll produce an object file, I'll feed it to a linker, but the goal is eventually to mostly just use the linker, like the direct linker output. So instead of generating an object file, I just say in the API, oh, take this module, throw it into the output, and it'll link it together like in memory, basically.
See, interesting.
Oh. Yes, Aaron. But I tell you, when I did that internal hotspot profiler that put stuff out on a HTTP port, I got so much dev love out of that thing. And then Azul wrapped it under a paywall, and I hated them for it. But you attach a browser to your running JVMs in production running, and then basically you had the read-only part of a debugger with all the profile stats dumped out. And everybody on the planet was like, oh my God, we've been trying to get this information forever and a day. Very handy.
So for Aaron's question, I was just wondering, why would you want a compiler to tell you where the time goes instead of like a performance measure?
It says the runtime. You didn't say the compiler. I want the runtime to tell me where the time goes. And in fact, the runtime could have that. Hotspot runtime definitely has that information. We count ticks and threads, and we count, we do runtime stack profiling, random stack samples, and collect them and sort, staple, and mutilate them.
Yeah, what they found with,
Yeah, and then right. And then, well optimized, but looks fast or whatever is not something a compiler can say. But we give you the assembly with, hardware profiling ticks laid out right next to it. And the assembly was annotated with all the Java types that we knew about. So
what they found with the
assembly
hotspot,
very well.
what they found with the hotspot collection, information collection, runtime profiling information, was the overhead was about 1%.
Yeah.
So, and the complexity for being able to turn it on and off didn't save much,
Yeah.
so they just never turn it off. So it's always running.
Yeah, certainly in the Azul collector, it's always on, and the overhead is no more than 1% because we couldn't measure it reliably with statistical means. So it's way down there.
Yeah, I'm talking about what's the name of the
The BEA J-Rocket team's
Yep.
flight controller or whatever.
Flight recorder.
Flight recorder. There you go.
Flight
Yeah,
recorder.
right. Yeah. Azul had something very similar. Has, as far as I know. Yeah.
Yeah, so flight recorder they claim has a 1% overhead.
Right. I can believe it.
So if you want to make Java 1% faster, it's really easy.
Yeah. But instead, if you want to make your app 20% or 50% faster,
Or
it's a hell of a lot
2,000
easier
times
to look at
faster.
the output
right.
of these things and sort what you're doing wrong than it is to try and do something else here. Oh, we got Levo again. I usually end up with 2 copies of Levo on 2 different cell phones. All right, what else? Thanks, Yasser. Are you Yasser or are you NeoGate? No, you must be.
Yeah, it's the username is negate, but what's it called? Yeah, Yazer's my name.
Yes, yeah, fine.
Where are you based, Chazzy?
I moved to Washington recently, but I was in Florida before.
I was curious because your accent, there's some Southern in it that I was picking up.
Yeah.
So I have a friend that lives in Washington who's from Louisiana, and he has a very similar accent to you. So I was curious.
Oh, really?
Yeah.
I've never had like my accent caught, captured like that.
I'd say I didn't speak with any accent, and then I go to Texas, and my sister says, "No, you got West Coast accent." And I go to the East Coast, "Oh, you got a Midwest accent." Apparently, I got somebody's accent. Actually, I go to Europe, and I get told I have an accent.
So I've been looking forward to an update from Yorick because he seems to have solved some of the questions we talked about a few weeks ago on the specialization stuff.
Ooh.
So
yeah, can you
tell
guys
us
hear
where
me?
Yeah.
Yep.
Okay, good. Yeah, let me see what I said. I think at a basic level it works. It's implemented. In a sense that I am still fixing a few edge cases, but the sort of larger picture is there. Simple programs work again. And I'm basically making my way through getting the standard libraries test suite to run again. And that currently involves fixing some incorrect code generation where if you call a method and that calls some other method through dynamic dispatch and it's generic and that then calls a method and somewhere along the chain it loses certain information about type parameters. So if something's supposed to be a reference as part of specialization, and depending on how you call things deep down, it ends up thinking, oh, it's whatever the default is, and it will generate slightly different code. That's a case where basically that happens because in my code there's certain places where it says, oh, if I can't find this information in this data set, we just default to this thing. And I'm now sort of leaning towards maybe I should just make that crash, because I think I would rather have a compiler crash than code that is, it's probably going to work most of the time, but technically it's still incorrect.
Right, and you have to get to the test case that triggers you.
Yeah, but that's the thing. They're currently happening because I simply had overlooked certain cases. And so it's this case where you can make it crash, but essentially once I'm done with this step, it should never crash in the first place. Which is, the ideal kind of crash, but that kind of raises the question like, okay, if the code is essentially dead code in practice, does it really matter whether you crash or return the default value? I'm not sure yet. I will probably
If it's dead,
tackle that later.
you should crash.
Yeah, I probably will. But there is an argument against that in the sense that if it had crashed, it would have been more difficult to debug what was going on because it would crash before spitting out my generated code, which means I cannot visualize the IR to see, okay, what is it actually generating?
Oh, well, then you have to go change your crash point to dump more info.
Right. So that's the case where it's like, for now, I'm just going to do a default value.
Right.
This future problem. Because in theory, you don't want it to crash. You just want a compiler error. So it sort of gracefully terminates, but still completes everything else. But yeah, it's not there yet. But anyway.
So in the land of large, complicated hotspot things, we had all these corner cases that only showed up rarely. Like if we deopt here, here's the current state of the universe. You're supposed to rebuild your interpreter state. But if you never actually take the deopt point, you can have a bug in that code forever and a day. And we eventually added flags that said like, do XXX a lot, whatever XXX was, and force all these weird cases to get executed. And that picked up a lot of corner cases that were just silently broken and no one ever knew.
Yeah, I think my long-term approach here is rather than in Rust parlance a panic that just terminates the program immediately, it will probably record some data, like basically a compiler error, which in my current setup, if a compiler pass produces an error, it just stops after, like it doesn't continue towards the next passes.
Right.
So you can still
Can you intercept
produce
in the
whatever you've gathered up until that point.
If you have a rusty panic, can you still grab it in the debugger?
Yeah. So you can set breakpoints and you get stack traces, so it's not completely useless.
Okay.
But for example, my compiler has an option where it will print the IR of a module in a Graphis file, which you can then convert to an image, and that's very helpful in figuring out what code is being generated, sort of how things jump around.
Yeah.
But for that to work, it actually needs to gracefully terminate so that it can actually write those files instead of panicking somewhere before that. So that's a change, for the future. Yeah, sort of code generation wise, specifically the challenge now that I've been debugging today is a case where it's very specific, also a bit specific to the type system. It's a case where you call a method through static dispatch, which is generic. That calls another generic method through dynamic dispatch. And that generic, that method, for example, discards one of those generic values. And essentially what happens at the dispatch, so at the dynamic dispatch site, it was actually passing, it's passing both the right and the wrong information at the same time. So in the test case I have, this final method that gets called is essentially, let me say this correctly, it has essentially access to 2 type parameters. And the thing what happened was it was given 3 type parameters along with their sort of specialization information. One of them was correct, as it should have been. The other 2 were given the information of a previous specialization of the receiver of the method. Or technically not, it was, sorry, I'm saying that incorrectly. It was essentially reusing type information of the caller, but that isn't correct if the receiver of the method is different from whatever the caller was called on. So in other words, if you have a method foo that you call on blah, and that method then called bar, it would carry over the same information, but then because of specialization, and it ended up being incorrect. This is a little hard to explain, without it taking 45 minutes. But
I've seen you do this before where you have trouble explaining it verbally, and I'm like, boy, it'd be really cool if you took some time, put like slides or pictures or something.
Yeah, I mean, if I know beforehand, I can do that. Yeah. Point being, 3 things were passed down. 1 was correct, 2 were wrong. That's basically the gist of it.
And Aaron's asking, why is this better than inlining the dynamic dispatch? You can't force the inlining or something.
Well, so if it's dynamic dispatch, you can't inline unless your compiler can determine, hey, there are, let's say only 2 types that implement this method. But even then, you have to figure out which one are you going to inline.
Yeah, right. Can you inline the site that's doing the dynamic dispatch and get static information? You probably still can't get static information.
So there is, as part of this specialization code, there is a very sort of basic version of devirtualization going on. And that's because it's actually to sort of ensure correctness, not even for performance reasons. But there's basically cases where, because of how I compile generics, the default approach is dynamic dispatch. And so the idea is, if we statically know the types, that dynamic dispatch is redundant. We can swap that with static dispatch. So in the case you have a generic function that takes some argument of some type parameter t, and you pass it in int, for example. Right? If you then call a method on that, it's kind of stupid to go through dynamic dispatch. So that's where it will then, if it knows, hey, the receiver of this dynamic dispatch call site is now a instance of a class, we essentially just swap the instruction to a static dispatch instruction.
Is this considered a performance optimization, or is this part of the typing knowledge?
I mean, it's... So originally I was going to do devirtualization entirely separately, like a separate compiler pass.
Right, it's an optimization.
Yeah.
To make things
and
faster.
What's the problem? The reason this is done is at the specialization pass is that if you pass a float or an integer to a, let's say, generic argument, those values are unboxed. And that means you cannot do dynamic dispatch on them because there's no class, v table, whatever to look up.
You have to box them or something different. Yeah.
And so I made the potentially controversial choice there to say that into float, you cannot cast them to interfaces. In other words, you cannot do your explicit dynamic dispatch on them because I believe for those cases, it's basically useless. And if you do need it, you can always introduce your own wrapper type. But that poses a challenge where if your generics default to dynamic dispatch, that would generate incorrect code for into float.
Wouldn't you just...
So what it does is
Java auto-boxing.
No.
Okay.
So what it does, if you have a generic method, generic argument, etc., you specialize it over an int, it will say, oh, hey, we know the class now. So we swap all those dynamic dispatch call sites with static ones, not really for performance, but so that the code is actually correct.
So
because we cannot do dynamic dispatch on int float.
Yeah, makes sense. So you're forcing to inline specialized versions to handle primitives.
Right.
Basically.
Yeah, pretty much. And that's it's the exact same logic as basically devirtualization, but I put it in this pass directly because I don't like this idea of having a case where you have a compiler pass followed by an optimization pass, but an optimization pass is required by the first one.
Yeah.
In my opinion, that should be one thing, right? It's like...
Right. No, there's a typing and then there's make it go fast. And you have to pass typing, right? And you don't want compiler optimizers are full of heuristics. Maybe I should, maybe I shouldn't. Here you must. So it's not a heuristic anymore.
And the idea for me is there, optimization is optional. You should be able to turn it off and get correct code. But for this particular case, you cannot do that because it would generate incorrect code. So it's part of specialization. And in the end, it's like, I don't know, 10 extra lines of code, so it's not that big of a deal.
I have very
Yeah.
similar issues in AA where I'm attempting very vigorously to not wrap my insert floats unless you wrap them yourself. So
Right.
I have to force some dispatch on specialized versions.
Yeah. And that's I thought about that. I thought, maybe what I specifically did is if you have an int or a float and you pass it to something that is typed as an interface, the compiler will reject it. And you also cannot explicitly cast it for the same reason, right? In an earlier idea, I thought, okay, what we could do is disallow that sort of implicit passing, but allow explicit casting and then box them as part of that.
A cast would box.
Right. So if you have, a function that says, I take something that is the toString, so construction outside, that is a toString interface, then you cannot pass it an int. You'd have to do something, your int as toString, and then you pass that. But then you end up with this case where for all methods that are defined on int or float, you have to handle the receiver being either boxed or unboxed, which in practice means you essentially have to compile them twice because the layout is slightly different.
Yeah.
I guess you could have. Yeah, no, you can't avoid it. And I didn't want to do that. It's probably complexity-wise not that big of a deal, but I sort of sat down and thought about it. I was like, okay, what are the cases where you have an int or a float? You want to cast into some interface to then do dynamic dispatch as part of that, and you do not want to use generic functions for that. I generally couldn't think of a case. The only sort of artificial one is like, oh, I have an array of a bunch of values that are that all implement the toString interface, and I want to call toString on all of them, but I want to be able to have that array contain, say, an int, a float, and a string typed as the interface, right?
Yeah, yeah.
Well, like that case is so rare
right.
that I'm just not going to bother.
It's
just use a wrapper type.
Polymorphic keys and values and hash tables, but the keys or the values are each typically all the same thing. They're all ints, they're all strings, there's not a mix. Yeah.
The only case where, or the sort of case where that kind of code happens is when you have like a syntax tree, for example, or some sort of graph where each type of node is represented by its own class and they all implement a common interface, and then you have like an array of nodes and do something with it. But for that, it already works because they're boxed values, so the compiler allows that. Right.
Yeah. Anytime I do any compiler and there's ints and float math going around, the ints and floats are all boxed in a generic. I'm a type with a constant int or whatever. It's boxed. Just has to be.
Right. Yeah. So outside of the bugs that I'm working on, it's I mean it works. I was pleasantly surprised by how few issues I ran into. At least when trying to run my test suite, I was expecting to like blow up completely, but it actually sort of ran some code before blowing up, which is a step in the right direction.
Yeah, good.
I think the biggest sort of frustration there is it's difficult to explain without first explaining for 2 hours how everything in the compiler works.
So I can tell you that the right approach is to put together ahead of time how you want to present this at your next conference you're going to present this at. Practice giving the talk a few times. It will force you to think about how to structure and organize, and that typically turns into, oh, here's the short description that everyone gets as to how I'm explaining what's going on. Because if I do just what you're doing and I mumble my way through all the cool things in my head, I do a terrible presentation, and I have done that several times in the past. I'm not going to say you did a terrible one, but I say I've certainly done terrible ones.
Right.
And if I take some practice and put together a visual discussion and I think through how do other people hear this, I suddenly just go, oh, I didn't talk about X. Oh, I need to present Y. And suddenly you get a reorganization of the data, and suddenly it becomes a lot easier to explain it when you're just talking it.
Right. Yeah, so my plan there is the language documentation has a section on the compiler internals. It's currently quite high level, but I do plan to explain these things in detail more. Part to sort of force myself to figure out, okay, how do you better explain these
How do
things?
you explain what's going on? Yeah.
Part because people are going to ask, but also a big part because a lot of these internals aren't really described by other languages. There's, for certain topics, there are like some tutorials written by people fresh out of university, for example, or maybe somebody wrote a book about some compiler that's been around for 20 years.
Right.
But these specific things like, how do they compile generics? How do they
How do you implement?
how do they do
vcall
inlining, and what
hotspot?
thresholds, for example?
I mean, I go into details on vcalls, but like, there's a lot of stupid things that a few slides of graphics would show would, I think, make them really understandable to everybody really quickly what's going on there. Fine.
Yeah, so it's part of there is to sort of the idea being, I guess the Boy Scout rule, like you leave the campfire a little bit better than you found it.
Yeah, right.
And so I want to write these things down so that the next unfortunate soul that goes through this process knows at least a little bit more than I did.
A little bit more than, yeah, right. Stumbled around. Yes. I was a Boy Scout for many, many years. Leave the place cleaner than when you found it. That was always the rule. Yeah. All right. Are we settled here? Sounds like progress.
Next topic.
Yeah, exactly.
Is there an AA update?
No. I got out of sync with Burning Man, and so I played a little catch up this last week. So I could do an ecstasy update if Cameron cares for me to dump ecstasy to
Sure.
Java translations.
Go ahead.
And then AA, I had my next most egregious test case for what to do with overloads when I started nesting them indirectly any number of times, and that popped up a thing I hadn't thought through on the theory side. So I have that test case sitting open in my debugger waiting for me to get back to it. But let me pull up what is a good way to go do this. It's either I can do it from a command line interface, or I'm going to want to, I can go find my command line interface here. Let's see here. Oh, I didn't make any shortcut. Maybe not. Let me try this from Emacs. Yeah, okay, so here we go. So let me hit the old share button. Let me find Zoom. Yes, come back here, hit the share screen, hit Emacs.
Maybe zoom a little bit.
Okay, so let me, yeah, okay, let me do font things, and then let me go pull up the source and the output to side by side. How about that? And now I got to shrink my window because it blew off the side in both directions.
It's it's manageable.
It's manageable now?
Mhm.
Okay, so
That's good.
So here is, let's see here, correct answer. Okay, top screen, ecstasy code, hello world, runs like main, I'm going to run it. Inject means pull in something from the external container, your import, it's an import. I'm importing something from an external container. An individual method, when it's run, individual module, whatever, has nothing. It's a pure mathematical entity, except what you inject into it, including consoles to print, file systems to run, which means that all things having to do with outside of your running code can be intercepted by your parent owning container and made to do whatever they want. All your file systems that you view could be chopped and limited to being what I want you to see, or managed by a RAM disk or any other thing, right? You can't tell. Okay, so just hello world. Down here, I have this code says auto-generated, and then it runs. And the auto-generated code says import some shit. Oh, and I'm generating Java code, and inside the running Java program, I just compile this class for name, load it, and run it. And there's a run, and he grabs the container. So if you look up here at hello world constructor, I get called as part of this by passing in the containing the external container, which is how I'm going to get at anything that container is going to let me get. When I say me as the running Java program. So in particular, it gives me a console. So I get a console here, and I call hello world, and I'm done. And the false at the end of hello world is like, do I do a new line or not? It's a default argument in Ecstasy. In Java, there are no defaults, so there it is. So then here's FizzBuzz, which says for I equals 100, here's a range thing. There's a console print of a switch. This is like Java switch expressions doing a mod, bunch of cases to string. Here I'm doing FizzBuzz down below, public class jFizzBuzz container. Here's the run method. Get the console that maps 1-to-1 with this line here. Here's the var x new range include the endpoints. Range is a trivial little constructor that has a high and a low that he changes to being inclusive on the low and exclusive on the high, and has the Java iterator syntax. So he just implements a Java iterator. He just counts 1-100. Yeah. Then I make some temps, which I have to have because Java doesn't do this kind of a switch expression directly. There's a console print. Then I'm into this particular switch I'm doing is question mark colons because it has multi-tuple matching, and I have to do a series of multi-tuple matchings as an expression. So there's go compute x mod 3, put it in the temp, and $T says return true. So blindly compute this as an expression and do more stuff. And I don't have a comma operator like I do in C. So I'm faking a comma operator right here. And x mod 5, and now I start doing real shit where I say, is temp 0 is 0, is temp 1 is 0, it's FizzBuzz, else fizz, else buzz, else toString. Add my comma to the console print, done. So that's a kind of a textual mapping, and here's the running code, 1, 2 fizz, 4 fizz, buzz, blah, 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 up to 99 FizzBuzz.
Which version of Java are you guys targeting?
Right now, I think we're headed for 21.
Yeah,
I want
21
expressions with patterns and instance ofs.
Yeah, that's basically what I was wondering.
But you can see that if the it's not an interop story per se, where a lot of languages on the JVM are about,
right?
I want to be able to use Java libraries directly and export my. But you can see here the code he's producing, he's passing in the container. It's like, okay, the generated code has no security because the front end, if you will, what gets emitted by the front end has already disallowed anything like that. So behind the scenes, he's allowed to cheat as much as he wants.
Yeah.
So.
And do you have to worry about people messing with you via reflection or like coexisting?
No, because that's what he was saying earlier. Like it's all mathematically closed.
Yeah, like you can't in Ecstasy ask the reflective question about the Java implementation.
But
So
couldn't someone in Java, like if you're using a Java library?
But you're not going to let you call into a Java library because this is an Ecstasy implementation. We're not interoping with Java.
Oh, you're not?
Are you working
on the original use case, which is, I want to be able to put, your company's payroll processing on the same server as JP Morgan Chase's, algorithmic trading on the same server as Russian hacker.
Right. So we have a hard firewall in the Ecstasy level, which we're bringing around at the Java type system and code generation level. So I'll never generate that code that breaks the Ecstasy security model. And in particular, I can't call random Java code. I can't call code I don't know what it does.
Okay. And I was also going to ask about I see that you prefixed FizzBuzz with a J.
I have a name mangling strategy. It surely will change in the future.
Oh, okay. Okay. So it's just like a.
Yeah, none of this is visible to the running code in Ecstasy.
Right. Right.
Do you do something along the lines of, like in Lisp macros, you do this gensim thing where it ends up having a number, which it ends up being fairly predictable. Like you could figure it out. It's not meant to be security, but it keeps you from when you're using a macro messing with its internal variables because you
Right.
can't really predict them easily.
So I'm name mangling to avoid all conflicts. So whatever name you pick, I will mangle such that it never hits an unrelated variable.
Yeah, I'm just wondering if you name mangle with any sort of random.
No. The name mangling is precise in the sense that I will not let you collide accidentally.
Right. Yeah. And I guess maybe it doesn't matter because you're in this sort of very specific environment, but a concept of name mangling can be like there's also a random, small random value in there, and you just can't.
Right, but that would I own all the mangled names. I own all the names, all of them, because I'm coming in from ecstasy, and I mangle them all. And if your names in ecstasy don't have a leading X, I can put a leading X in mine. And if they do have a leading X, I'll put a leading Q. And if they have a leading Q and an X, then I know that I don't have anything that starts with a leading Q, so I'll just let it go through. There's a perfection you can do on the name mangling here. The user can't hand me a name that I won't mangle. The user of ecstasy.
So you're using the raw AST to.
So I'm using a raw AST to do basically. Wonderful. Let me do this. To do basically a string mapping almost. I walk the AST and replace.
You're generating Java code. You're generating a Java code from the ecstasy AST tree.
From what we call the binary AST.
I'm
so
reading
it's actually
AST.
The back end of the front end.
Yes. The translation, the handoff between
These
ecstasy.
This here raises some questions. One of them would be they have to be compatible in order to generate the ecstasy semantical feature. You have to be able to generate the Java equivalent.
That is the task laid in front of me.
So the backend of the front end should be lowered enough in order to be compatible with Java. So
that's what Cliff's doing.
Right.
So so the back end of the front end is definitely not designed to be compatible with Java at all.
Yeah.
So Cliff has to figure it out. But fortunately, Cliff knows Java pretty well.
I'm making good headway on the thing. So here is a set of things. So here's an if, and it returns a question mark colon of a nested array.
I imagine most of the semantics of the ecstasy has a pretty straightforward, I would say, translation to Java. But
yeah, there's some that do and some that don't, and I'm tackling ones that I know do first.
Which one is the dinosaur in the room?
Yeah,
would be hard to translate. Okay, the elephant. Fine.
Yeah, it would be mix-ins and interfaces have a different question. We have people in the chat here who wasn't paying attention. Levo says security question when I'm ready. Let me go 10 more seconds, then security questions are all good.
I have a couple of questions too.
Yeah, sure. So this one here, you see var pattern equals permute. It's just a direct mapping. I could probably actually get the comments in line as well. Result is a new array. Here's result is a new array of array events.
Why that makes sense? Why that makes sense?
Standard mappings using ints and whatever, and expression tree remapping. So this one's easy. The formatting string I thought was kind of fun. Permute 3 equals the formatted 3, and you get a console print down at the bottom here that says the string permute 3 plus a call the permute function with a 3. Just inlines the code, all works.
So generating Java code, it still permits a high level generating sort of not really quick translation. If you target the bytecode, what would change?
The reason I do the high level is because it lets me debug a whole shit ton faster. It's easy to read. I can take this code and fucking cut and paste it into IntelliJ. I haven't yet set myself up where the output of the source and the .o that's built in memory only because it class for names in straight memory. I could dump them to disk. and then tell IntelliJ to go find these things here, even though they're generated on the fly. I'd have to nuke them at the start, and because the debugger stops you in the middle, and you left over all these leftover bits, and I've changed my generation strategy. All the source code's wrong, so I would start up, nuke these directories clean as part of startup, then fill them in with source code that I've generated and .os or .class files I've generated, and then IntelliJ would find them, and then I could debug that generated code directly. I'm not there, but I'm like, I could get there, I bet.
Why would the ecstasy mixing impose a challenge to translate to Java?
There's a bunch of them, but one of them, like I said, classes and interfaces and mixins are unrelated to Java directly, and they're not a tight fit.
I remember a time when Scala traits are not exactly the Java interfaces because they allow implementation. You generate the base class, and it generates the structure. It generates the base class with if it has an implementation, and that extends the interface, and off you go.
I will probably have to generate variations of Java classes for an ecstasy class with interfaces and his mixins that will vary according to which mixins are being applied. So my theory there is I am going to have a bunch of wrapper Java classes in order to get the typing and the dispatch to work out how you expect. I don't know if I can make ecstasy interfaces become Java interfaces. Maybe not. Maybe
Why not?
Something different.
Mostly.
I imagine they're not far off. So, does anyone have to ask the question?
Okay, so Levo had one. Then I have some other stuff I can talk about as hard problems. So that's one of the hard problems. There's more that I'm aware of. So let me go take questions for Levo and then Derek.
Yeah, so you mentioned about having multiple processes or multiple people's code on one machine. One thing I heard that a lot of people that I don't know if this was a proof of concept or if this was actually an attack, but a process was creating a pipe, and another process basically deleted and replaced it with its other pipe, and it just did an attack like that. So do you have any security for files or file systems or pipes
you
or
can't
whatever?
You can't read or write a file. You have no access to any file system except through your wrapping container, who does whatever he wants with your requests.
Are there pipes in ecstasy?
Every one of those things, like you say, I want to make a pipe. Your wrapping container decides what he wants to do with that request. He gives you a wrapped pipe or not, or he fakes it. And he dumps everything into a byte buffer and hands it back to you as if it were a pipe-like thing. But you don't get to control.
This is the fundamental difference, I think, in ecstasy, is that before ecstasy, everything was built like you have your hardware, you have your firmware, you have your BIOS, and it's this layer cake, and your code runs up here, somewhere up here. I don't know. I can't see myself on the screen, so my hands may be off the camera, but your code's running up here, but it gets to call anything below it. If I'm in Java, I can call anything because there's no security manager.
I can call a file system,
I can call any operating system function. I can load any library. Yeah.
And just format your C drive straight up.
So in ecstasy, when your code is running in ecstasy, there's nothing under it. Nothing. Like there's no OS.
Yeah.
There's no runtime libraries available. You can't load libraries. There's no BIOS.
printf.
There's no int28. There's no printf. There is no printf. There's no console.
Right.
There's no disk. There's no network.
I like that.
Yeah.
And so, and by the way, like we invented this, but at the same time, it's been invented 100 times before. So if you look up capabilities, the same concept, we just didn't know it existed. So we had to invent it because we weren't good at research. I didn't know Matt at the time. If I had known Matt, I would have saved a couple of years. So if you look up capabilities, the concept is very widely being adopted in other places. But the whole idea is that if there is nothing under you, it makes it really hard to do bad things.
Yes, Matt, you are a gem of CCC.
So I
very much appreciate
have a question there about capabilities, because capability is something that I looked into for Inko and occasionally revisit. The idea that came to mind with that was I think a year or two ago, there was that security exploit where a JLog or some Java logging library,
Oh goodness,
you
yeah.
gave it like a particularly
shell.
formatted string, it will like write to disk or something.
Yeah,
like
he
So
had,
it
he had
had
access to a generic
JNDI.
shell.
It had
Yeah.
JNDI syntax allowed in the, and so you could pass in the URL JNDI syntax, and JNDI is Turing complete with access to Java. So basically, if you passed a complicated enough thing as a URL, and then that happened to get logged, it would get picked up. As it got
Yeah.
logged, it would get picked up and basically interpreted on the server, and then you own the server.
Right.
I may have messed up the explanation, but I'm somewhere.
No,
in the
that
right
sounds very
universe.
close, though. Yeah.
Right. So that's that's where something I briefly experimented with this setup where I think I did it at the function level where you could annotate the permissions that you would give it. So you'd say, oh, for this to be able to write to, you know, the disk, it needs to have the IO permission, for example. And then they would have to cascade with calls.
Right.
So if I want to call a function that has the IO permission, the calling function must also have the IO permission.
Great. I've seen this approach used. It's actually used successfully in a couple of languages. So
Right. There's I think Coca does something similar. They generalize it as an effects system.
Yep.
That's essentially what it is. I think if I remember correctly, because it's been a while, the main issue there became that you can very quickly end up with this sort of cascade of permissions where, you know, something deep down needs file system access. And so basically the entire call chain needs to also have file system access.
Yep.
Yeah, I think that's
But
correct.
that then still essentially gives it unlimited file system access.
Yep.
Is that similar to how Ecstasy
Nope.
does it?
No. So first of all, the granularity that you're talking, I think you described it well. So you're talking kind of a call chain granularity. I'm making
Yes.
up words to try to describe the concept, but you can imagine, you know, if I end up way down here and I have to be able to do something, then I have to force everyone who called me in that chain to also be able to do it, or something like that. Or there's some protected mode that occurs in the middle of it where I say, like in Java, what's that thing, Cliff, you do with it's basically a using statement, but you're saying like, I need special permission for the following block of code. You know what I'm talking about, right? Someone?
I missed your, no.
Yeah,
Yeah.
I get it. It's
Yeah.
similar where
So I believe
Yeah.
what
Protected.
Cameron was trying to say is that you can just allow the code that it needs the current permissions to do your job and eliminate it from far off. You
try
don't
with
need
resources?
the whole chain.
Well, it's something like try with resources, except basically it says I have to do. I may be called from someone who doesn't have permission, but at this point, I need
Inside
permission
that
to do
block.
the following
Ins-
thing, and you see it all through the JDK. I can't remember what it's called though. It's like something protection.
You're talking
or
about
something.
the security permissions model. Or the
Yeah,
security-
that thing. Yep.
Oh my God, that thing.
But that's nothing like what we're doing. So
Right.
our granularity is container.
Yeah.
So if you're inside a container, anyone inside that container has the same rights to do whatever, right? So we create a container to run an app. It's not like we delineate between foo and bar in that container and say, oh, foo gets to do whatever and bar is not allowed to do anything. It's like, no. As far as you know, you're in ring 0 inside your container and everything is in the same ring, right?
I
So
would
if you're in that container-
equalize this to a Docker. So inside a Docker, it's what you put it. So you have all
Yeah, and
that.
I'm not talking
Yeah.
Docker containers, just to be clear. These are ecstasy containers.
Ecstasy,
So
Software
yeah,
only.
they're
yeah.
actually inside the same process. I can have 10,000 different containers inside the same process.
Yeah.
Okay.
So now I'm in one of these containers. I don't know who my parent container is. You know why? Because there's no such question. I don't know what the disk is because there's no such question. There's no op called int21h, right? There's no way to even ask the question. So what he was showing you in the example is that inject concept. The inject is basically, I'm in a container, I can't do anything, but I need to print to the screen. I don't even know what a screen is, but I'll call it a console and I'll say, dear God, please put a console in my hands. I don't know what it is. Maybe it goes to disk, maybe it goes to screen, maybe it goes to dev null. It doesn't really matter. Inside my container, I get handed something that I can call. So I inject it by interface type or by immutable type. And what I mean by immutable type is, say, int or string. By interface type, I mean something like console, which is an interface that has a method called print. So I say inject the console, something shows up. If I reflect on it, the only thing it'll tell me is that it's a console, so I don't know what class it is. I can only see its interface, or Cliff, what we were talking about yesterday, pure type. So it's opaque, its implementation, its configuration is opaque. I can't cast it to anything that it's not. So inside my container, it's only a console, whatever that is. It's just an interface. And so basically, this is the way we do file systems. This is the way we do network, whatever. So inside my container, I say, give me a file system. I'm handed something that has the API of a file system, but I have no idea if it's a disk or a dev null or whatever. Like,
or a pipe.
my
or anything.
parent container totally controls what I'm handed.
Yeah.
So
And then that's tree-like and recursive all the way down.
right. And a container can create a container. That's a secure operation because you can't give anything to your container that you can't get yourself. So basically it's, again, turtles the whole way down.
So how do things get injected into it originally? Like, is there just like some magic built-in set at like the root?
There is a root container. And the root container has all the permissions the OS will give it, including format your drive or whatever, everything.
All right.
And the root container decides what he hands down to the next level container.
Yeah.
Which would
One of the
typically
things-
be everything. If you're just trying to go after, I'm reading and writing the actual disk.
Here Cliff will play the capabilities guide because he decides what code to generate and what code to reject.
Right. So somebody wrote ecstasy inject console. I said I gave a container when I constructed this JTest1 tuple Java class is playing the role of a module and a class in ecstasy inside a container. The container is passed in as a Java object that stores a final field somewhere in X1 class. So I have the container of my parent so I can ask it questions. But the code I generate here is only the questions I'm allowed to ask of my parent container. Things like, give me a console.
Yeah.
Is it fair to say that containers communicate through interfaces? As Cameron said, you cannot speak through the implementation. You can only ask for the interface and the method which it contains.
At the ecstasy level, I believe they're all interface-like calls. At the implementation at the Java level is TBD. I will give you the effect that ecstasy gives you, but I may end up having direct access of some kind.
Which is fine. Like that's the other reason why we can't just give you Java interop, because then there'd be no security. So
right.
Yeah.
Right.
So I then have a small follow-up question because this it's a bit funny. This is very similar to the idea I had. The difference was there that one challenge was I wasn't really sure how to inject things from sort of the root, in the sense that you start your main function essentially, and somewhere you need to decide, so what are the root permissions? The idea I had there originally was that you would, for example, for file system operations, you would create a file system object, and that you would then use to like open files and stuff like that. And so, but then at runtime, it would then do this check like, hey, if we've already created a file system object, you can no longer do that. So that some, function deep down can't just say file system.new.
Yeah, I think you're better off passing it in.
Right.
Like in AA, I'm going to pass you in a top level sys name.
Right. The thing there is, I think another language looked into this. I forgot which one. The problem you run into there is if you say what you could do is you make this part of your main signature. So instead of int main with no arguments, it would be something like int main file system socket. It basically has a whole bunch of arguments that are the root capabilities, right?
Right.
But then you have this problem where if you either have to allow allow that argument list to be
There's another way
dynamic?
without doing an argument list, which is what
Right.
we're doing here.
Right. So, well, the difference, as far as I can see in Ecstasy, you essentially plop down a inject line, and then it sort of generates the code from that.
It basically makes a Java global variable, class
Right.
static variable, that
The-
is scoped to the container that
Right.
talks about the parent container.
So
And
the
let me
idea
add-
I
let me add
originally
one
had.
thing, Yorick,
Sorry, go ahead.
real quick. And just to be clear, like you're solving a slightly different problem because you're pre-compiling everything statically. So it's a different challenge. So I'm not really equipped to comment too much on that. But oh crap, I just lost my entire chain of thought. Oh, that hurts. Oh yes, metadata. When we compile, like the whole thing is a tree. Cliff will tell you, like, I must be fond of trees. I'm a tree fetishist. Like, so the entire compilation unit is just a tree, right? So it's a tree of source files. We compile it into a tree of structures and ASTs. But the metadata gets rolled up as well. So, and I can't remember where this project's at, if this is already done or not, but basically all the metadata of what gets injected is already there. So when you create a container, you have to give it a type system, and to form the type system, you give it one or more modules. And at that point, we know everything that could be asked for as an injection. And part of the contract, again, this isn't all fully implemented yet, but part of the contract is that when you say, okay, I'm willing to supply those things, only then does the container get created. Because if you're not willing to supply the necessary injection points, then you can't create the container. You can't supply what it needs to run. So there's a two-way contract there between, and it's a runtime contract, not a compile time contract. Anyway, so I was just adding the metadata concept.
Yeah, I added the link to the doc. Essentially, there were a couple of things why I sort of put it aside for the time being. But one of them was that if you want to sort of encode the so the idea I had was that these capabilities are represented by just regular objects. So if you want to open a file, you need a file system object, and the presence and having access to that object is essentially your capability. But this creates this problem where, at some point at program startup, you have to create those capabilities. And you can do that using one approach is just, you do something like file system.new and you get a new object. But then you need a runtime check to make sure you do not do that again the first time after that object is created. Otherwise, you can cheat the system. The second approach is the idea I had was, your main function has a set of arguments, and those are the capabilities passed in. And then the compiler will look like, oh, the type of this argument is file system, so we give it the file system, capability, for example. We end up with this problem where the signature of main will differ based on the capabilities you need, which then complicates the sort of startup process, because when you compile the code, you have to change how main is called. And you end up with these things where if like the capability, like things like, oh, what if I have two arguments that are both the same capabilities? Is that a compiler error? And so, point being, at the time I felt it was just something I didn't have enough of a.
There's another aspect too that we always have this saying when we're talking about security, and it's like this question you always have to ask, and you've probably heard me say it before, but it's, who are you protecting from? Right? Because I guarantee you in this case, you can't protect from Cliff because he's the one generating the code. Like if Cliff is evil, he steals all the money in the universe because he wrote freaking hotspot.
That would happen a long time ago.
Systems out there. Yeah.
I had my chance. I didn't take it. Sorry.
So, but the point is, like, how would you protect against the guy writing the back end of your compiler? Well,
How
the
do you protect
answer
against
is
Intel changing your chip
Yeah.
transistors?
exactly. You don't.
You don't.
Like, so
exactly.
you never protect against them. So when you're doing capabilities, the question is who are you protecting from, or basically who are you trying to equip with the protection mechanism, right? And in this case, like for us, we know who we're protecting from. We're protecting from the person providing code to run in a container, and we can't trust the code, right? So that's why we have the container, and that's why we allow it to do nothing unless, you can add, subtract, multiply, and divide inside a container, and that's it. Like whatever the binary AST gives you, that's all you can do. Everything else has to come from the outside. But it does have, I wanted to highlight a couple advantages too that, in retrospect, I didn't think of when we started this. One of them was the serialization problem. In a lot of languages, serialization, like Java, for example, is a huge hack because you can't do serialization in Java because of security. Well, things have changed over time with respect to security manager and whatnot. But like, if you hand me an object and say, serialize this, I have to reflect on it. So I can reflect only on the public aspects of it, right? What do I do with the protected and private fields, right? How do I serialize them? Or do I have to generate code? Like there's all these questions that it raises. In our model, inside the container, there's zero security, zero, absolutely none. Our security model is whatever's in the
mention
container
that
is
public, private, protected in a container are convenience. They're not security.
right. They're for your purposes of organizing and hiding stuff from yourself. Think about it like when I'm in idea.
But Adrian, you can in Java reflect on private fields. Yes.
Right. Well, now that the security manager's gone. Yeah, exactly.
Oh, all right. I see.
But in ecstasy, basically, you say X dot, you have some reference called X, and you say X dot. What does IntelliJ show you as a list? Well, it shows you the public stuff. Or if you're inside an X, maybe it shows you the protected stuff, or just the private. In other words, the public, private, protected is a convenience for organizing your own code. It's not a security mechanism.
I got 2 questions.
Oh, wait. Derek had a question, and he's been waiting longest. So let's go back to Derek.
Yeah, well, I had 2 questions, but one of them was not a very exciting one. Just about going back to the name mangling. Like, does that prevent you, if you do it too dynamically, wouldn't that prevent you from doing partial compilation? And is that a concern, or?
There's no dynamic name mangling here.
Oh, okay. So that's not a very interesting question. The more interesting question was, what is the approach that you actually take for doing the source to source translation? Like, are you using something similar, like a compilation type approach, or is it a template, or?
It's a dumbass tree walk. I got a tree.
Okay,
I walk
it's
a
just
tree.
a tree walk. Okay.
So somewhere in the world, I walk a byte code, a array of bytes. I call a slightly compressed decompressor here. It makes, from a set of tokens, he makes a bunch of tree things who recursively call back and make more tree things, and I get a tree. Along the way, if I look at one of these things here, let's look at for range. He says, oh, I have some special regs. I'm going to ignore it from the now because they don't show up very often. I have a left, I have a right, I have a body, and it's because it says something like for long X colon new range of whatever. That's like, do the left, just do 4, do the left, do the mid part, colon, do the body, close paren, or close paren, do the body, whatever. It's just a textual translation at the moment. So J code here is a tree walk. I walked a tree and said, spew it out as Java code. Sometimes I do a little translation along the way. Sometimes I don't. So block's another easy one. A block has to do scope locals because of the compression strategy. So the reader says, give me the current kind of locals, go do a recursive AST walk. So this is co-recursive with the main AST walker. Pop the locals, make a block. Okay, block just records the kids as I'm a tree node with children. Somewhere down here in the pre part, the pre-post, mid-post, this is you're either overriding J-code to doing all the printing, or you're overriding, or J-code calls pre, mid, post. So if I do the pre, I get an open curly like a Java thing. I increase my indent, I make a new line. There are no temps, I'm ignoring it. Every mid statement puts a semicolon in a new line. You get statement, 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 like a teletype, just printing out. Post says close your curlies, decrease your indent level. That's the pretty printer for block. Didn't do any mangling. Who did bin op does some mangling? There's a rewrite pass. Here's rewrite. If the op is ... it's a range operator in ecstasy. There ain't no such thing in Java. So I replace you with a new. And the new takes his type as the word range, and it's inclusive because it's ... Or it's new, and IE is the appended thing there because it's exclusive. I get a range operator. If you look at the code, it'll say new range, textual dump of the range bounds. If you're an equals and you have to have a .equals because you're Java and not ecstasy, you get swapped out for an invoke call that calls the equals function. So I'm doing a little bit of rewriting at the moment, though. It's very dumb and easy. You get a
there's
simple.
no real like structural changing or anything happening.
Not yet. I think I have to, but not yet. Let's see here. That's what X class builder for a little high level thing here. So J class body says print auto generated package, some default imports that are not changing. Public class, your name extends. I need a constructor that takes your container. That's your container there. I now walk the AST looking for construct methods, which is the ecstasy version of a new of an initializer, which at the class level turns into a CL-init. So down here I get a CL-init if you've got something, and I call J-code, call it AST construct J-code. So AST walks and builds me an AST from a pile of bytes. J-code pretty prints it. So there's no smarts going on there. Here's the method guy. When I walk looking for all your methods, properties are a little weird. I'll have to go look at static properties. That's global statics. But here's JMethod. JMethod says, hey, you're a public. Here's your return type. Here's your multiple return types, which those are to do because I don't want to do with multiple returns yet. Here's your argument list. So print the method name, open paren. Here's your arg list, which just says go fetch out things. I have a translation step that takes ecstasy types to Java types, which is full of things that say unimplemented when I don't know what I'm gonna do with it yet. Print to close the arg list, AST J-code, and then print a name and do whatever search, and I'm done. And then the AST guy just says, give me the pile of bytes. That's the C constant pool, pile of bytes, and some mapping between bytes to ecstasy structures called parse. Do rewrite, that's the trivial rewrite, and then hand it back. That's my AST that's been built and rewritten one step, and then I'll call J-code, which is just a dumb recursive walk and print. So it's really stupid, except there's a lot of details in ecstasy that turn into a lot of nitpicky details, but there's nothing deep yet. When I start doing class things, I'll have to go deep. Also, ecstasy has an interesting cross-container communication model, well, services model for doing multi-threading, which will require probably a deeper level of intercept. Is that?
Yeah, it's cool. It's nice and simple. Very, very like.
Yeah, that was the intent here, was that I'm just going to do something simple for a while, see how far I get. Yeah, and as much as possible, use ecstasy concepts to Java. Sorry, go ahead, Cameron. Sorry.
I was saying your coding approach is depth first. Meaning you chase all the way down.
Yeah. Oh yeah.
Yeah.
I've done this, all my life. I chase because whenever I chase wide,
because you're not afraid of changing
it. Two things here. So the reason to go deep and not wide is a coding philosophy, but whenever I go wide first, I always run into the problem that I end up inventing all kinds of, I think I'm going to need this stuff that I never need. It's never the right thing that I built. Hey, as part of going wide, I need a generic way to handle class printing. I need a generic way to parse ecstasy objects. I need a generic way to do and they're never the right thing. So it's always sort of a waste of time to go wide. Like half the code you make is throwaway, and then you don't do the important half that you didn't realize was important because you didn't go deep. You go deep, you get the important shit thrown in your face right away, and you have to tackle some hard problems up front. And then you realize why it's important, and it feeds back into the rest of the implementation directly. Find the important parts first. So that's me going deep. What did you have the other comment? I've lost my brain.
Well, because you're not afraid of throwing it away.
Oh yeah. And then I know it's not 100%. So a lot of also happens here is I don't Java doc or comment hugely on code that I haven't lived with for quite a while without changing it. Because if I spend a lot of effort on Java docs and then discover it was the wrong thing, the docs were also the wrong thing, and it was a waste of time. Again, it's another broad versus deep. So a lot of these things don't have deep.
I was going to say, I totally agree with that. I always find that writing docs like late in the process is pretty straightforward.
If I found that I'm using a function in multiple times, like 3 is my usual cutoff, I'll stop and ponder that this maybe is a correct API and now it could have docs. Load a U8 by translating through my pool of bytes and getting a U8. I don't have any docs on, but I could, but it doesn't need a huge 5-line docs for a function that literally is just a pass through to go get a byte from an array of bytes. These other variants that are all just pass-throughs, they got a little bit of comments because they're easy, but they don't do anything except look one step through.
So I don't know if it's been mentioned in one of the older CCC meetings, but what is ecstasy for?
Levo, you keep getting kicked out.
So basically what I described, which is the ability to host applications in a strongly co-located fashion. So our goal is to hit about 10,000 apps per server from a hosting point of view. So being able to load and unload applications as necessary, be able to track their memory utilization in real time, CPU utilization in real time, and it's basically time sharing scheduling for all practical purposes. But the benefit is if you're using 1/10,000th of a server, you're basically using 0. So from a point of view of a cost model, from a point of view of efficiency, from a point of view of carbon footprint, like it chops the average way down. And it requires the flip side of that is it requires 1 million applications, right? Because you can't schedule 4 things and hope to make use of a system that is designed to pack 10,000 onto a server.
Yeah.
When I say 10,000, I don't mean 10,000 running apps. It's 10,000 apps that you can send a request to and get a response in 100 milliseconds. But whether the app was running or not is a different question.
Yeah, it may have been sleeping or waiting for stuff.
Exactly.
Yeah.
So
we may pickle you to disk and pull you back up on demand. So
if we do a great job, we may be able to cut data center sizes by a pretty significant factor.
Ooh, that'd be interesting.
I think it'd be awesome. I'm excited about it.
That's the
you should be
financial goal in the end. That's the reason.
Right. The financial goal is that we would hope to be able to profit from a reasonable slice of that cost savings.
Yeah.
Over time.
Yeah. All right. Any other questions? Levo, you were trying to say something maybe.
Yeah, so I had 2 questions. One was, did you do any research to find out how much of the Java ecosystem is just not going to work if you only made them capabilities based?
Did I do any research on how much of the Java would not work?
Yeah, because it seems like a lot of things that I've seen that if you had to give permissions to it, it would just not understand and just have null exceptions and stuff.
Yeah, so Java code would not work in such a model, and that's what we learned from the security manager. So there's no, but that's the other thing. You can't just call Java code from ecstasy. There's no such concept.
On purpose. So
Right.
there will surely be, I'm already calling runtime pieces written in Java, but that's all code that I include in my trusted computing base. It's no untrusted Java code. Somewhere under the universe, when you said, give me a new range, I went to an X run and I found the range guy, and he's this. It's my trusted computing base portion. It's pretty dumb. There's actually 2 versions right now. There'll be 4 in the end. This is the next function. The IE version just calls into the other one. Oh, you know what the II one is? It's actually a little more. The I version differs because it has a +1, because it takes it from inclusive to inclusive exclusive. So every iterator on a new range doesn't have to care about whether you're inclusive or exclusive or not. So, but that's part of my trusted computing base. So I am trusting some Java code. I'll have hash maps and array instances. And here's my array that has the things that I want out of an array list that ecstasy can do and will want to do. So it doesn't have a whole lot of stuff. And I'll probably add more, and it may look like an array list. And I maybe could use a Java array list directly at some point if I have maybe a little extensions to it. But the point here is that this is trusting computing. I'm not calling, hey, you handed me a jar file from the web, go run it. So it's not that I don't run any Java code, it's that I only run trusted Java code.
Yeah, that answers both my questions, even though I only asked one of them.
Yeah, okay.
A twofer.
So
Right.
what would be the challenge? Circle back to our
Yeah, what are the
parse.
hard things? Well,
Yeah.
the actual ecstasy semantics for mixins and interfaces and classes is somewhat different than the Java version. So I'll probably have to take all of the ecstasy composition of an in class by its collection of interfaces and mixins and the like, and make a custom Java class, which has an interesting mapping to a hierarchy because of inheritance and an ecstasy. I want to map to inheritance in Java. So virtual calls in Java or in ecstasy become virtual calls in Java because the virtual call mechanism in Java is well optimized. So to the extent that I can map, directly from an ecstasy concept to a Java concept, you get much more performance out because the mappings are all optimized on the Java side.
Exactly.
The service model involves actors passing messages back and forth. The default worst case scenario is I actually have a mailbox queue between unrelated Java threads, and I'm passing messages literally back and forth. The obvious optimizations here are that most of these things will be called from one to the other directly in short, narrow, easily optimizable, understandable, and I'll just inline the service.
Right.
And Java won't inline across a thread boundary that way. So I'll have to look hard at the generated code. Am I manually inlining where I can detect that a service is legal to do so, or can I trust the C2 compiler can do this inlining? Because the service in question is like immutable and it just does a constant thing and has no updates. But if the service in question is implementing a hash table with gets and sets, a big cache, it's a hash table. He has one thread who's servicing the hash table so he can do updates. But I might want to have many reader threads and rare writers. Then I may pay more attention to how that's implemented and decide, oh, I'm going to swap out the written implementation of hash table in ecstasy for Java's concurrent hash map or non-blocking hash map. And at minimum, allow the readers to run in parallel without taking a box or passing message. So the readers get inline and the writers have to pile on the queue. And then inside, they'll take a lock, but whatever. There are some things to be done on that front for getting performance where the expectation is we're going to have what Java is now calling, not Valhalla, Loom, fibers. So a service in ecstasy is essentially intended to be like a fiber in Java, super lightweight, make and throw away. People talk across services, supposed to be really cheap. So that'll be a challenge. I have little int versus big int or little long versus big long as a semi-challenge. I'll see how bad that gets. Right now, I'm adding versions of everything that I'm intercepting some ecstasy libraries with Java libraries that have known a known long, like array I64 is known that its elements are lowercase long elements. So he has the more efficient version, and then that breaks as soon as you do any sort of reflective thing. And I'll have to see if I can keep this, or I have to always have the reflective thing, and I'm forced.
So I have another question actually. How do you deal with exceptions? Like, do you?
Well, that's the ecstasy question, which I haven't had to deal with yet.
They're exceptions.
Yeah, but what did that mean?
But are they
Everybody has a
Java
different idea.
exceptions? Like,
Cliff will have to decide when he gets there.
Yeah,
They're
the
either gonna-
implementation depends on what ecstasy exceptions do, Cameron, and I don't know what they do.
Yeah, I mean, they're conceptually similar to Java's, but because Java doesn't have the service concept, that barrier, that membrane between services will complicate the, again, like everything.
Certainly in the
I
land of H2O, I took exceptions on one node in a cluster and I forwarded them across to another node. So that when you said do a parallel map reduce across 100 nodes and a terabytes of data, and everyone blew the same fucking exception because your code was wrong. We gathered the 1 million exceptions you got and said, oh, they all look like this. And here's an exception. And at your point where you said, oh, data.map reduce of yada yada, you got an exception thrown that you would catch in IntelliJ, literally at your desk in IntelliJ. And he would say,
That's kind of reconstructing the future because
Yeah.
the stack traces are scattered across the threads. And
yeah,
you
I
can
would deconstruct the stack traces. I would, in fact, take the recursive map reduce stack trace elements were all said I have variable counts of internal map reduce according to how many divide and conquer steps were done. And I would collapse them, and every exception would have different counts of these. You'd collapse them all and say, these look like the same exception. I'm going to fold you up and just count them. Oh, you have 1 bazillion of these exceptions that all look the same except that variable numbers of map reduces in the middle and variable numbers of cross node cluster communication lines as well in the middle. And those all got collapsed. And I said, here at this line in your Lambda you handed me, you blew an exception and you blew it 1 million times. So that
But
was
in
the
ecstasy-
thing that I've done before.
in ecstasy layer be semantically, because what it means to throw exception ecstasy, it needs to be handled by the Java side because they will be constructed like features or fibers for what it is, and something has to have the ability to throw exception but not block the
Well, you have to
whole-
be careful here. On the implementation side on Java, I can do whatever I want.
Exactly.
Of course,
So
but you have to maintain the ecstasy
I have to
semantics.
maintain ecstasy semantics, but I don't have to throw a Java exception and map that to an ecstasy exception. I do not have to do that.
But you could.
I
could,
don't.
but don't have to. Yeah.
That would be a poor decision because it would
Well, it
be-
depends on what the ecstasy exceptions are allowed to do.
okay.
Right.
Yeah.
So the other obvious one for everyone who throws an exception is you have a pair thing that's a result in a binary that's either an exception or the actual result.
Mhm.
So there is another standard, another standard sort of implementation strategy that says I have to check the return type, and the return type is the thing I want, or it's an exception. And,
Yeah,
and
we
maybe it
talked
has to
with
flag along with
Cameron. Are exceptions values in the ecstasy?
Yes, they are const classes.
Mhm.
I don't know, Cliff, do you have the source code, the ecstasy library source code there?
Most of it's lying around. I don't have my tags on it running right now because I haven't bothered in a while.
And
Um,
Derek has a question. I interrupted.
Well, I wanted to ask about sort of stack traces as well. So, I mean, one thing is exception semantics and dealing with the fact that you have potentially lots of them happening in parallel or something, but you've got this code mapping. I've dealt with, CoffeeScript back in the day and various languages that translate from one thing, usually they translate to JavaScript, but you guys are translating Java. It's the same problem though. That stack traces take a lot of interpretation because lots of things have changed. So
the goal here is to be an ecstasy runtime execution engine. The stack traces will have to say ecstasy things, never Java things.
Right.
yeah. So is that something that you do? I was just kind of trying to think about how I might approach that. Like, is that something you do while you generate code, that you generate some sort of mapping as well? Like,
If I'm going to use Java exceptions as ecstasy exceptions, then at some point I'm going to have a way to reverse a Java exception to the ecstasy, exception lines and source code bits and however an exception looks in ecstasy when you stack trace dump an ecstasy exception.
but I guess regardless, even if you don't use exceptions, you need to sort of correlate any given line of code to its source, right?
The AST tree I'm given has that data in it. It's got the source code in it. So there's line numbers and source code lying around. I'll have to figure out the mapping from the given line numbers to which portions of the AST are going to generate what line numbers when they throw.
Yeah.
Which that might be yet a format change for the AST. It has yet to happen.
Did you guys say earlier that you can see through private and protected variables?
Within a container, there is no security. So within a container, private and protected mean a convenience for you and how you organize your code, but you can see through them directly. They have no security.
So if one container passes data into another container, let's say the data is called employee, and the bottom container or the container uses employee data, but it has a supervisor member, and the supervisor also points to the CEO. Could that container work its way to the CEO and access like CEO things?
If one container passes an instance of a data structure to another container, that second container, when he asks questions about the object, has to go get permission from the first container to go follow that line. And Cameron can correct me if I misunderstood that.
That's roughly right. So you can basically think of it as, in most cases, what you're passing into the other container is a proxy. There are some exceptions to that where you would pass the actual structure, like an int or a string. The details are not decided.
Go to the original one, which is I pass you a complicated object.
Right, you'd pass a proxy in that case.
Right.
And but the class that you pass, the thing that you pass in is a interface type. So and it has to be a type that exists in both type systems.
So the question is, can I take an object I'm going to pass to somebody else and filter what I let that other guy see?
Yeah.
And do I filter
by copying the interface type that the interface, if you will, is the filter?
Yes.
If they exist in both.
Take a semi-concrete example. Just thinking about, like, imagine I've got a proprietary service and I want to allow an ecstasy user to use my proprietary service, but connecting, from my perspective, when I connect to it, I may not want to let the customer do everything that I can do. So then, is that possible in ecstasy, since the security model within a container is?
Yeah, you just create a new instance of something that represents what you allow the container that you're injecting it into to do. So think about it this way: there's no magic to this, right? Like, the idea is whatever interface you inject into the container, that represents the capabilities that you're providing to that container. By injecting it in, you're saying whatever's there, they can use.
So wherever you have security boundaries, you have to have inter-container communication.
Conceptually, yeah, absolutely.
Yeah, conceptually. Semantically, that's how it happens. The optimizer under the hood might do all kinds of shortcuts. Conceptually.
But the idea is, instead of having to protect the entire surface area of every DLL on your drive and every exe on your drive and every .com file and every bin file, every SO file, every interrupt, and just the infinite surface area that we have to protect against today. Now the only things you have to protect are the holes that you poke through from the outside container into the inside. The holes that you poke through are called injections. So basically it means you go from infinite to a countable set, which is a big improvement. It doesn't mean that you can just ignore those those poke through points because they are poke through. So whatever you pass in, I mean, to Levo's example, it's actually a pretty good example, thinking back to it. If I put into that container something that has access to data, I'm basically granting access to that data into that container. So if I don't want that data to, like, I should never put anything in that I don't want to,
Let me take Levo's example and show you how you might stop that look. So I have an employee, he has a manager that goes to supervisor whose manager is CEO.
Mhm.
I want to hand it off to some other guy where I want a one step to supervisor to be allowed, but no more.
Right.
So I want to change the object I'm handing over as an employee. I want to say, this employee implements an interface that lets you look at his name, rank, and serial number. It lets you look at as a supervisor whose supervisor itself is hidden. That's the interface. Then I pass the employee object to this other guy, but as the interface that has a restricted access set.
Right.
And then the container who receives it has an interface. And the interface says, I can see his name, rank, and serial number. I can see his supervisor. That supervisor is shrouded or hidden. I can't see that super.
But what's really cool about your answer is you basically just said, anytime I poke something through, I need to think about what it is.
I need to think about what I'm handing over. Yeah.
And that's exactly, like, that's the message I would say, is that injection says, I am choosing to place something into your container that you wouldn't ordinarily have. Therefore, I need to think about what capabilities I'm sticking in there as a side effect of that.
I can hand you raw file system capability, or I can hand you a file system that's been truncated at the mount point that looks like it's mounted at some root-like thing, but I know internally I've mounted it on some local temp space with 10 megs of space to write in and has no access to /home/ etc. /password or nothing.
Mm-hmm.
Yeah, good. Yes, I think so. This is Adrian saying, security here. And the answer is always security. You have to define, what the borders are. What slipped through the onion layers at each layer is what the next guy gets to rob and cheat and steal on.
So by saying Cameron that it's handed a proxy, that would mean if you want access to the restricted to the private array of the object, you will have to make a service call to get it, or so if it needs, let's say it's part of the computing some public function which relies on the private state. So how would the private state be sent there? Do you send, I want access to the private? Do you send the private data in some other manner? Because I can imagine a scenario. Yeah.
Don't confuse optimization with semantics.
Right. Oh, the other thing is that you're injecting an interface. So the interface isn't, so this is, Cliff hasn't quite gotten here yet. So let me do my best to explain this without confusing anyone. But when I ask that object, what's your class? It doesn't give me back a class as an answer. It gives me an interface. It says, oh, like in Java, I'm a runnable. Oh, no. I didn't ask you what you implement. I asked you who you are. Like, what's your class? I'm a runnable. Well, what can I do on you? Well, you can call run. That's it. This is what, so it's, in other words, the beyond, so there's no, I can't say, okay, I want to cast, I know that behind the scenes, because I looked at Cliff's code, I know it's a super duper, owns the entire filing system object. I want to cast to that so I can access the filing system. It's like, no, I'm not that class. And it's like, well, I know you are. I saw the source code. I can cast you. And it's like, nope, it throws an exception, cast. If I cast it, what's the exception? Whatever, cast failure.
The thing it's not.
The main thing, you cannot poke through the interface to its private parts, no matter how you try. You can just call the public.
Once you cross the container boundary, it is, for all intents and purposes, the thing that it got declared as for that container.
Okay.
So it's a shrouded employee or limited visibility employee or whatever, how you want to call it. It is no longer an employee.
I think we call it masked in our.
Well, I was making up Levo's example about don't be able to walk up the management chain to the CEO.
Right, I see.
There's just,
So if you're not meant to call it, you just cannot call it. So
yeah, right.
But,
It's
but also
not in the namespace. You can't compile the ecstasy code.
keep in mind who's creating containers. It's not, this isn't something a typical application is doing. This is something that, an app server is doing, or a database server is doing, right? So the idea is, in general, we want application code to be written as if everything is synchronous, single-threaded, right? And yet somehow run it in a way that everything is asynchronous, multi-threaded.
Mhm.
So that's what the service and container model, in theory, allows us to do.
Mhm.
In theory.
Okay.
Well,
Cool.
sounds good on paper.
Sounds good on paper, exactly.
Okay. Any other topics?
Everyone-
I have one that's a bit less technical, so maybe a bit boring, but it relates a bit to the strangeness budget of languages.
Our favorite
But-
topic.
But not again like last time. More, I was just wondering because a lot of times we have to make design decisions that have to that make trade-offs based on user friendliness, maybe, or like, yeah. And the thing is, like, maybe these considerations are often hypothetical, or maybe just not so driven by experiments. So I was wondering, did any of you ever conduct, because many of you have implemented languages, right? Maybe that other people used or something. So I was wondering, did any of you ever conduct a controlled experiment where you give a person who's never tried your compiler just 20 minutes and observe them how they deal with just a compiler and the docs, and ask them to implement maybe just a simple program? I think that would be cool. I read this somewhere, and I would like to do it, but I was wondering if anyone did that.
I had office mate in grad school that was doing things like that. I'm not
And how
claiming
did
that
it
he
go?
got his PhD or that what he ended up discovering was useful, but as soon as you ask those questions, by the way, it's the same problem that Henry Ford had with the automobile. If you ask people what they want a better horse until they see an auto and use one. Up until then, they just want a better horse.
So the benefits are not immediately obvious.
Yeah,
So
if the benefits
so-
are not slap in your face obvious, well, what the hell? What the hell do you need block structured computing when you got Go2? Until you use it for a while and then you just go, oh yeah, this works out better. No, so you just be careful. You get a biased answer there. Everyone's
That's
biased
true.
by their current opinions, and their current opinions are, we've never seen whatever you've got that's new and different, so we think it's shit. We don't know what to do with it. So whatever,
So
I guess I
what-
would even be asking people about their opinion. I would just like to observe how quickly they can like maybe there's a new feature and they will be able to grasp it more quickly than I imagined before.
Sure.
That would be interesting.
Apple did a lot of usability studies and discovered interesting things about how to do things. And I think that was really cool research, but they still had to fight the issue of, well, it has to look like what I've gotten on my Windows desktop for buttons and ribbons and whatever, or else I don't know what the hell to do with it. They're just saying you're headed into that domain. All right, Alan, you were going to say something?
Oh, are you asking me?
No, I thought I heard you say something, but maybe not.
No, I didn't.
Okay, fine.
I mean, like, I do have opinions on the Strangeness budget. Like, I think that a lot of the time, like the amount of strangeness people will accept is greater than what you imagine. In particular, and in particular, I don't think it's a good idea to focus on like existing users. Like, certainly there are a lot of software developers in the world who have used Java and C++ and so on. And so when they use your language, they will of course be, what was the word Dyker used? It was like mentally crippled by those languages. Oh, no, that was it. Mentally mutilated. Now I remember.
Crippled, mutilated, fine. Gotcha.
Correction is important.
Right.
So, and so I think it's better to focus on new users who've never programmed before. And so there, the question is not, is this feature familiar? The question is this feature, easily learned by someone who has no programming experience?
But this takes to different perspective because the new developers aren't, let's say you have to convince the new developer to try your language, but based on what they will learn, that's
Right.
highly, let's say, and you have to do.
Nintendo game era emulator is what they'll be excited about and learn fastest. Because it's quick, obvious feedback and has nothing to do with anything that goes beyond that.
So
Well,
you're stuck.
The biggest question that new users have is how many jobs are available using this thing that you're
Of
about.
course, yeah.
Yeah.
How would they pay? What
Oh,
was
we
the
got
was the
kicked
salary?
again.
Well, that's not true at all, because like there's people who use this Scratch programming language, and that's like this visual blocks programming language. And a lot of people learn it as their first programming language. And of course, because it's such a simple, easy to use language, there's no jobs in it. So
what's your definition of a lot?
of a lot of jobs.
Because like no, a lot of people learn using Scratch, because I would think that it may be a lot, but compared to virtually any mainstream programming language, it's not a lot.
It's not a lot. I would claim not a lot.
I would compare the Scratch programming language to training instead of the real thing, training with the sword, training with a stick. So you learn the basic concept, but you never learn with the real thing. So that's maybe somewhat for the children, okay, it's maybe acceptable because they are not immediately searching jobs. But for a person who tries to learn a new programming language, it seeks immediate benefits to be able to acquire from the programming language.
So
what are the interesting things you can? Oh,
Wait, let's let Alan go.
Yeah,
You've been trying to
okay,
say something
for
here.
the numbers, okay. As of like a few months ago, there were 112 million registered user accounts on Scratch. Okay.
Yeah, but I bet you there only a tiny fraction of those are actually active.
And for comparison, there are about 13.3 million C++ software engineers.
Yeah, but I think the Scratch registered users is not programmers.
I think the metric you're looking for is MAU, not total accounts.
Yeah,
this is
so
like the old days
monthly
in the web when people talked about hit, and you could just put more images on your website and get more hits.
Okay, so the monthly active users is more like 1 million, but like, I mean, I think you have to measure reach, right? Like Scratch is used by at least 1 million people today. So like,
man, kids.
So when I look at resumes, quite often the people I'm looking at, they use Go, C, C++, assembly, Java, Pascal, Swift, and like 45 different languages. And I'm like, okay, so tell me about your last Swift application that you built. And they're like, well, I've never actually built an application in Swift. I did this online tutorial thing because I was checking out iPhone development. So I put it on my resume just in case.
Yeah.
Because like I know C++, but I haven't worked in C++ more than one day in the past year. Right? Not more than 10 days in the past 5 years. Right? So am I a C++ programmer? Well, I mean, I've written hundreds of thousands of lines of C++ code. I guess I'm a C++ programmer, but would I be hiring you to do C++? No.
Well, there's a difference between a guy who took the online course and wrote the little toy examples from a guy who did 100,000 lines a decade ago.
2 decades, 3 decades. I don't know, like a long time ago.
Now it's too much.
Yeah, exactly.
I think that's the other thing is like you have a complex language like C++, right? Someone who's been using C++ for a long time will probably have forgotten about the areas of C++ they don't use.
Right.
So in
They
some
should,
sense, they have
and
to
well,
learn
they
the
should.
language like a new user anyway for parts of their language that they haven't used for a while. So that's why I think you should focus on how new users learn the language rather than how existing users say, oh, this is weird.
Okay, but that one gets into the whole C+ is too big because different communities use C++ with different ways. There's definitely a thing where in my company, we write this style, and in this other company, we write that style.
I completely disagree with Alan because Cameron probably has an idea of who his customers are. I'm pretty sure new users are not going to touch containers and have 10K apps.
That's a
in
different
server.
story. His intended use case is whoever got hired by people who would otherwise pay Amazon $1 million a year for continuously running applications. So
But-
it's
but
not the users, it's the payers of the data center.
Yeah, Cameron first would have to try to convince the company to use XTZ, so there is XTZ demand for the job. So it's
Yeah,
kind
right.
of
Yeah, there's a different story here. It's like, okay, you're running 10,000 Amazon servers a month. Let's see if we can cut you to 1,000 Amazon servers a month. Okay,
so-
what's the benefit to you for that? Well, you have to get some programmers to write ecstasy, and you shaved off
And it's a
100,000 a month,
huge
let's
chicken
say.
and an egg. It's a huge chicken and egg problem too, right? And that's what Tito is right about. But you know, one of the ways you solve that, and this is how we're solving it, is that we're going to host for free. So you bring your first app, it's free, not for a week, not for a month. It's free forever. Like, as long as you stay within a certain capacity, like it costs us nothing to run. Why would we charge you? And the thing is that once developers realize that they can actually build valuable apps and host them for free, they're going to start doing that. Then they're at work, and at work they're told, oh, you don't have budget for this, but I need it done next week. Guess what they're going to pick? Right. And it's going to go into production. And as it goes into production, the security team's like, no, we're not letting you run that app on a server that runs Russian hacker code. Like, we want our own server. Okay, well, you're going to pay for it. Like, and not as a mean thing, like we can, you know, we can host efficiently. We can save you money by doing it. So it's like, it's just a point of light. And we did the same thing actually in the previous startup that Gene and I worked in, which is we gave developers like free licenses to this stuff that was running stock exchanges and bank systems and insurance companies, right? And they would build their entire application and go to production. And they're like, and they're like, well, what do you mean we have to pay for the software? It's like, well, the application's done and ready to go. Like, if you want to put it in production, you have to pay for it. Like, this is going to run our website. Like, and sure enough, companies pay for it because, you know, it has high value and they can demonstrate it. So the problem is, how do you survive until people build high value things that they're willing to pay for? How do we survive?
I still don't really understand how you're compacting like 100,000 servers into just 10,000.
It's really easy. Like, how many cores do I have on my phone?
Yeah, probably 8.
8.
Or
I have
4 to 8.
800 applications running on my phone right now. 800. Like, I think they're running because when I click on them, they show themselves where they were 2 days ago when I was running it. Like, it's running, right? Like, it couldn't have saved off its state and restored in a fraction of a second. That's impossible, right? Like, I have 800 apps running here and it's using no power. How does that work? If I can do 800 apps on a phone, I can do 10,000 on a server. Are you freaking kidding me? I'm being silly, obviously, but you get the idea. Like, what is an app doing? I told the story before about when we bought Sun. They sent out an email. So I'm working in the Sun office at the time. They sent out an email. I was working for Oracle, but we moved into Sun offices. So they sent out an email and they said, okay, you have to tell us what servers your code's running on. Otherwise, we're going to shut them down and recycle those servers. Nobody responded. So they sent a second warning. They sent a third warning. And then they just pulled the power on the data center. The entire data center went down. Because you know how you find out who's using something in the data center? You turn it off. Guess who complained? Nobody. Over 90% of the hardware in the Sun data center. So they had already taken out the parts that were actually being used and put them on something that they didn't unplug. The other 90% had been running for years, using power in the data center. You know, you're talking about each one of these servers. Cliff, you worked there. I mean, they were 100,000, 200,000, 500,000, $4 million servers, right? Pull the plug on them. Nothing was running on them. Well,
that's just a sad story.
This is
it's
very
like a PS minus EF. There were tons of things running, but nobody was using them, right? So they pulled the plug.
That's not the results I thought you would be getting at.
I'm telling you, that's exactly what I want to do with every data center out there.
See, I thought it would be dozens of people who complained, but not hundreds.
Well,
But-
maybe 3 complained. I don't know. I didn't hear any complaints.
Wow.
Because a lot
That
of the
blows my
people,
mind, actually.
like a lot of the people that needed that for a project, they put it in place. You know, it takes effort and time and work to recycle things. It's far easier to just leave it there, go find another job, switch companies. Like those servers were just
You know
burning.
what's even more
dinosaurs.
mind-boggling is that almost all of those servers have a refresh schedule, and so they'd be periodically buying new equipment at the same spec as the old one and replacing it and cycling the machines and
There's
everything.
a reason Oracle bought Sun and Sun didn't buy Oracle.
Yeah.
I've seen this in government and other places as well. Same problem. There's this whole really boring field called ITIL, which I don't recommend anyone look into because it's so boring. Which is about trying to deal with this in a bureaucratic way.
I'd rather let software deal with it for me. Right?
Yeah,
Like,
it seems like a good idea.
I know when an HTTP request shows up for something. So at that moment, it has to be running. 200 milliseconds later, I don't care if it's sitting on disk or not. And all we have to do is get Cliff to implement that.
I'm going to want a little bit of money at some point.
Me too.
Oh,
Working on
okay,
it.
you're doing it for free? Is that?
See, I thought data centers would have some kind of metric of like how much memory and network I/O and disk I/O is happening on the machine, so no one noticed. Like, that's blowing my mind.
You have no idea how much information, like and this came up on the conversation about logs the other day. Like the problem is a small amount of information makes sense. And Archer can tell you about this from looking at JVM stuff, and Cliff can tell you the same thing. But there comes a point where you turn the knob up and you have so much information that if you actually look at the details of the information, you can't. Like, it's simply, you can't keep up with it. So like when managing 5 servers, you can do, but it's a completely different problem to manage 1,000 servers, and it's a completely different problem to manage 100,000 servers. So the way you manage 5 servers is nothing like the way you manage 1,000, and that's nothing like how you manage 100,000. But we still manage 100,000 in a lot of places like we manage 5.
Yeah.
That's why the containers, the instrumentation, the software to manage all these computers. So I imagine it would be a little somebody's now because somebody's tracking data center utilization or server utilization, and actually you do not reserve a machine for something. You free some resources to run your job, to run your test, to run whatever you want, and machines use it for something else.
Yeah. So this is called a serverless model, which is to say you don't really care about what server your stuff's running on. It just has to run when the request gets there. And so we designed Ecstasy for that use case. So there's no loop that you're sitting in a while true on a object.wait or something like that. Like, basically you run when you're called, you return when you're done, and the concept of the application is running is a virtual concept.
One idea that comes to mind that can fit in this model is to have let's say an lazy model. You try to, let's say the services themselves can migrate to a different server. So you always try to keep the lowest possible servers. So there's some metric, or they die. So if they die, they try to migrate from the other server to keep the lowest possible utilization of the lowest resources they can. So that can be a nice idea.
It's a scheduling problem, right?
Yeah. And so, and then different things can pop up then to some neural network that can predict that this this app or this service would be called soon, so they wake up prematurely to answer the request. So
Right.
there are all kinds of things possible.
All right, folks, wind it down. Any more last minute questions?
I was just wondering, like, for ecstasy, since you mentioned serverless, like, is it stateful? Like, how do you persist data between calls?
Yes, of course it's stateful.
So is it? Yeah.
Yeah. But we can take that state and put it on disk and bring it back. There's no, because we're generating the code for that running application on the fly, Cliff.
Yeah.
I mean, it's all serializable because we can make up what serializable means in any way we choose to. So rolling
So
it out
any
to
heap
disk,
allocation, all of that is like persisted. So that sounds a bit like orthogonal persistence, right? Is that a bit similar to
I've
that?
heard the term, I don't fully
Don't know
understand.
what it means. Yeah.
Ah, interesting. That's funny. Yeah, because like at my company we're doing something similar, but on a blockchain. But I won't talk about it. But basically we have a WASM runtime, and we also have like basically something very similar to containers that are running. And the idea is that the language we use to develop these WASM modules, it has this concept of orthogonal persistence where basically like any heap allocation is like after your call is finished, your function call is finished, any objects that you created are like frozen in place, and all of that is implicit, and we use like a page based like file back allocators, and so that sounds a bit similar.
There will be a serialization strategy. It'll map to Java somehow. I generated code for serializing in the past. So I'll probably generate serializers along with every ecstasy thing that has state. You'll get a free Java serializer method thrown in. However I do it, though. That's an optimization.
There's a lot of seems to be a lot of innovation in database ideas in the Clojure world. If you guys have ever looked at that, but all that stuff runs on JVM.
So we do database as well. So that's separate from the statefulness of the running code for some definition of running.
Yeah.
I don't
Go
think your
ahead.
customers care about. I don't think your customers care that much about performance. They care about security. Yet you have performance cliff on your team.
So think about it this way: no one's ever complained that their stuff was too fast. So first of all, everyone cares about performance. Our top 3 priorities don't include performance, but it doesn't mean we don't care about it, right? Like if it feels slow, no one uses it. That's the way.
I got pulled in because it was the things they were running were 100 times slower than when I mapped them to a straight up Java generated model and ran it. So there's too slow is too slow. There is a too slow
Yes.
Yeah.
Not just slow but also big. So we use 100 times as much memory as we should in the proof of concept. So yeah, I mean, 2 orders of magnitude is nothing to sneeze at. So right now we can get to probably 5 apps on a server, but when Cliff's done, we'll hit 1,000, and that gives us 10,000 because 9,000 sit on disk. So something.
I
like
just have a last thing I was wondering, like wait, did I
You're the only
interrupt
one with
him?
the last
Oh,
thing
sorry.
you were wondering.
I'm sorry. I didn't see that.
Go ahead.
I'll
Ethan.
shut up.
No, go ahead. While you're on.
Okay, basically, like maybe I missed it, but like lowering this binary AST to Java, like, what is the goal there? Is this like how it's
The goal is
supposed to
a second cut instead of a first cut, better implementation. There may yet be a third cut, but a Java has a nice DC. It has a nice code generator baked in. It has all the features, has threads and everything else we have baked in already. So I could have lowered it to C, but I'd lowered it to Java because I think it's going to be a lot easier.
All right, that answers my question.
Cliff knows someone from the hotspot team.
Yeah.
What was that, Alan, you were going to say?
Oh, so I was just going to say, see, the way I understand ecstasy is like, it's too simple to run, 5 services on 5 servers. So instead, you're going to run 1 million services on 1 server.
I don't know what too simple has to do with 5 services on 5.
Yeah, something like that.
All right. I'm going to call it because I have things I need to do this afternoon. All right. It was nice talking. It was fun. And, hopefully next week again. All right. Bye-bye.
Yeah.
Bye.
Bye.